We're Team 24. I'm Parker.
And I'm Daniel, and this is our submission to the AEP Challenge. As AEP knows well, every electrical box deserves to be monitored for dangerous heat levels, overwhelming humidity, and any malicious tampering. But why don't we apply those same standards to our residential electrical boxes? That was the exigence for our solution today. We've decided to seek a solution that is both practical and cost-effective. When doing research on our alternatives in the market, we did find that the technology exists, but no one is taking the initiative to implement it into residential housing. The negligence of electrical boxes is responsible for over 24,000 home fires every year, 400 deaths, and over $1 billion in property damage. While planning for our project, we had to ask ourselves some questions. One of those questions was, which hazards can we monitor for the most effective solution? Now, among many other things, such as exceedingly high currents or corrosion to the box itself, we landed upon high heat, high humidity, and tampering.
And now, let's move on to our prototype. Our prototype features multiple key components that allow us to measure these levels. And that is an ultrasonic sensor, which captures the door opening, which is indicative of tampering, as well as an atmospheric sensor that captures both the temperature and the humidity inside of the box.
And that ties into one of the key features of our product. Although it's nice to have an alarm that may go off when something's wrong with your electrical box, that's only really relevant if you're home. And oftentimes, these problems can be very urgent. That's why we've set up our Raspberry Pi to deliver text messages giving the specific issue to the owner of the house or whomever may be responsible for taking care of the electrical box. So here you can see our code. And currently nothing's being displayed because there's no hazards within our electrical box. But let's say that we go ahead and open the door. Now, I open the door, and you can see in our code, it's now repeatedly telling us that there's an issue, and that the door's open. Now on top of that, I get an alert, the door has been opened. So now we'll test our next feature. We've got a spray bottle which uses spray water on our humidity level sensor. You see it's right here, and now we're receiving alerts on our computer that our humidity is too high for electronics. Although this project, in terms of assembly, mainly encompasses electrical and engineering knowledge, its breadth and complexity spreads much wider than that. Having a holistic understanding of the humanities and how problems like these can affect people all around the globe is very important when coming up for solutions that are most practical and effective. So the impact of this project, as I mentioned earlier, tens of thousands of homes are lost every year, not to mention the lives of people and the billions of dollars spent in repairing property damage for what can really be brought down to electrical neglect. Lastly, in terms of challenges that we faced during our project, there were many. Being freshmen, we haven't had a lot of experience with these electronics, and therefore there was a big learning curve of understanding how to assemble the parts and use the technology to capture what we wanted to effectively, not to mention the wide array of part choices that we had, and we wanted to make sure that we chose the best ones to create a well-rounded product. We were able to overcome these goals by consulting our peer mentors, as well. We were able to overcome these problems with the help of our peer mentors and the event organizers, as well as consulting our resources on the internet, which was in all very helpful to complete our project. Thank you guys for listening. We're Group 24.